Powers of 10. 10 to the first power is 10. 10 to the second power is 100. Those are powers of 10. When we're multiplying or dividing by powers of 10, we're simply just moving the decimal point. When we're multiplying, we're moving the decimal point to the right. And when we're dividing, we're moving the decimal point to the left. So if you look at this problem in front of you, this is the very first example. All we need to do is place the decimal point in the product. If you were right now to just move this decimal one place and move this decimal one place, the problem would be, you don't have to write this down with me right now, it would be 56 times 12. And if you multiplied that out, you would get 672. But our original problem was not 56 times 12. It was 5 and 6/10 times 1 and 2/10. What we did is we multiplied 5 and 6/10 by 10 to make it 56. And we multiplied 1 and 2/10 by 10 to make it 12. To make this problem easier. So altogether we multiplied by 100. That means we now need to divide by 100. Right now the decimal point in 672 is right there. When I'm dividing by powers of 10, I'm going to move the decimal point to the left. So I want to bring it back in this way. I want to bring it back in so that it's a division problem of dividing by 100. So that means I need to move it 2 times back in. So there's dividing by 10. There would be dividing by 100. So I would want to place the decimal point right between the 6 and the 7. So 5 and 6/10 times 1 and 2/10 is the same as 6 and 72/100. Now think about this another way for a minute. You're taking a 10th in this number and you're multiplying it by a 10th in this number, correct? What is, you don't have to write this down with me, what is 1/10 times 1/10? 100th, right? So that means my decimal point should give me out to the 100th place. That's another way you can think about it. We also can just use the steps that are right in front of you, which says 1, pull the decimals out and multiply the numbers together, like 56 times 12. 2, count the digits behind each decimal place. There was 1 digit, 2 digits total. Place the decimal in the product according to step 2. So we bring it back in, moving to the left 2 times, since we had 2 digits behind the decimal place. A 10th times a 10th gives me 100th. Or I multiplied it by 10 to make it 56. I multiplied it by 10 to make it 12. All together, I multiplied by 100. So, what's the opposite of multiplying? Dividing. I need to divide by 100. Example 2 says find the product using mental math. Let's look at that one next. Here our problem is 8/10 times 6/10. Now think about this. If the problem was just 8 times 6, we can do that in our head, right? 8 times 6 is 48. So I'm going to put equals 48 here. Now, our original problem is not 8 times 6, right? It's 8/10 times 6/10. We are taking a 10th times a 10th. Should we have a digit in the 100th place if we're taking a 10th times a 10th? Yes, because, don't write this down, just like before, 1/10 times 1/10 gives me 100th. So that means I need a digit in the 100th place. If we use our steps given in our notes, it says pull the decimals out and multiply the numbers together. That's what we did, right? If we pull those decimals out, it would be 8 and 6. So 8 times 6 is 48. It says count the digits behind each decimal point. I have 1 digit, 2 digits. Place the decimal in the product according to step 2. So we want to move that decimal back into our product according to step 2. That's where the decimal point would be if it was 48. But now we want to bring it back in however many digits were behind the decimal, right? So my new product would be 48/100. Final answer. Do you see how we found the product using mental math? We just pretended the decimals weren't there and it was just 2 whole numbers, 8 times 6, and we multiplied them. We got 48. And we said, hey, well, we're really taking a 10th times a 10th, so I should have a digit in the 100th place, since a 10th times a 10th is 100th. So then we move the decimal point back in. Let's go ahead and let's look at example 3. Example 3, pull the decimals out and multiply the numbers together. Let's do that right now in our notes. We're going to pull those decimals out And we're going to multiply the numbers like they're whole numbers. If I pull this decimal out, the number would look like 34. So I'm going to write 34. If I pull this decimal out, the number would look like 67. We haven't finished step 1. It says multiply the numbers together. So you go ahead and multiply the numbers together, and I will as well. So 4 times 7, 28. 7 times 30 is 21, 22, 23. I'm moving to the tens place. 4, 2, 18, 19, 20. Add those place values together. I get the digits 8, 7, 2, 2. Now this is what I got when I multiplied 34 times 67. But my original problem is 3 and 4 tenths times 6 and 7 tenths. So step 2 says count the digits behind each decimal point. So here I have 1 digit, here I have 2 digits. It then says on step 3, place the decimal in the product according to step 2. So that means we want to move the decimal point back in 2 places. Right now, the decimal point in this number over here is right here, 2,278. I need to move it back in, 2 times. So I'm going to show that right now. I'm going to move it. There's moving it in 1 time. There's moving it in 2 times. So my final answer would be 22 and 78 hundredths. Now let's back up and see why these 3 steps work. You are taking a tenth and you're multiplying it by another tenth. If we look at that, don't write this down. We have 1/10 times 1/10. That gives me 1/100th. That means I should have a digit in the hundredths place, right? My decimal should represent the hundredths place. Also, if we look at this, 6th graders, we moved, don't write this right now, we moved the decimal 1 place to the right, so we multiplied it by 10. We multiplied 3 and 4 tenths by 10 to make it 34. And we multiplied 6 and 7 tenths by 10 to make it 67. Altogether, we multiplied by 100 to make this beautiful multiplication problem right here, to make this multiplying decimals easier. If we multiplied by 100 to make a different problem, yet still helpful, then we need to divide by 100 to get our final product. And that's what we did when we divide by 2 powers of 10, which is 100, right? 10 to the 2nd power is 10 times 10, 100. You move the decimal 2 places to the left.
I'm serious.